In this video, I will show an implementation of a linked list in Python 3. To be able to implement a linked list, the first thing I need to do is to create a node. So let's define a class linked node. And then let's create the init method. For the init method, I'm going to use two parameters, data, which is going to be the value stored in the list, and next, which is going to be the reference to the next element in my list. So I'm going to have an attribute underscore data because I want to protect my data, so I want to encapsulate the data. I'm going to assign what I've got in the parameter data. The next thing I need to do is to assign next to another attribute. Let's call that other attribute underscore next. However, before doing that, I need to ensure that next is an instance of linked node. So let's use an if statement for that. So if next is none or is an instance of linked node, then I can assign it to my attribute self underscore next. Otherwise, what I want to do is to raise a type error. The parameter provided in the attribute, the value provided in the parameter next is not the right format. So I need to ensure here that I'm going to have something to control that information. So I want to protect my program. Having done so now, what I may want to do is to define properties. So I want to define a property for data. So I will be able to retrieve that just using the name of the attribute. And I'm going to use the decorator at property, and the name of the method is the name of the attribute or the property. Similarly, I want to be able to change that value in my node. So I need to create a setter for it. I'm going to use the decorator at data.setter. Similarly, I want to do the same thing for the tail. So in that case, I'm going to create a first property to be able to access the tail. Tail represents the next. So here I know that I make a small difference between the name, but it's because to make sure it's a reference to what we've seen during the lecture. The name could be next if you wanted to. But here I try to make it consistent with the previous lecture. Then I want to do the setter. So I want to be able to modify that reference to the next element in the list. That's something we need, for example, when I want to insert an object or delete an object from the list. So it's very important to be able to do so. So here I'm going to pass a node in the parameter. So again, I will need to make sure that the node is of an instance of linked node. So I need to make the test here. So if the node is none, or is an instance of linked node, then I can assign it to my attribute. Otherwise, I will raise a type error. So now I've got my class linked node set. The next thing I need to do is to define my class list. So here I will define a class linked list to represent a linked list. So first, class linked list. Then I'm going to create the constructor. So here, when I'm going to construct a new list, I'm going to define it as an empty list. I'm going to use the two parameters I mentioned before, the front and the tail. So we can say either the head or the tail, but here I'm going to define it as front and tail. Okay. But I want to do something else as well. If I want to know the size of my list, I will have to traverse all that list, which is pretty expensive. So it will be better for me if I had an additional attribute to store the size. So I don't have to traverse the list every time to be able to know the size of my object. Because it's a property that is going to be used very often. So here I'm going to add another attribute called size. Again, I encourage you to create the property for that specific class. So an attribute to be able at least to access the size. And again, probably what I will do is implement the operator underscore underscore len underscore underscore. So one of the operations I want to look at is to append to a linked list. So we've seen that append was very efficient. So I need to ensure that my code will be efficient too. So let's define append. So what I want to do is to have a value and add it at the end of my list. So the first thing we had to do was to create a new node. So to create a new node, I'm going to call the constructor from linked node. So here I'm creating a new node with the value as a parameter. Then I need to ensure if I'm at the list or not, if the list is empty or not. Okay. So if front is none, that means that my list is empty. So I need to check that property first. So if self front is none, that means my list is empty. So in that case, it's pretty simple. I just have to say that the front is pointing to the new node, but the tail is also pointing to the new node. What I will have to remember later on is also to increment the size of my list. But here, that means I've got only one element after the append. So the front and the tail point to the same object. Otherwise, if that's not the case, that means I've got at least one element. So in that case, I can modify that tail. So when I want to append, the first thing I need to do is to modify the reference to the next object. So here, the tail should point towards the new node. Once I've done that, then I will be able to say that the new node the tail is equal to the new node. Okay? Having done so, the final step is to make sure I'm going to update the size of my list. So very important to do that, otherwise the attribute size will be out of sync compared to your real size of the list. So that was one of the efficient operations I've done before and demonstrated in the lecture. Another one I can do is to pop an element. In that case, to pop at the front of the list. So I'm going to define that method, pop, and here is just to be able to remove and return the first element of the list. So there is a case I need to look at, which is if the list is empty. So ideally, I will create probably a method is empty. But if that's not the case, what I can do is to check that size is equal to 0. If that's the case, that means I've got an empty list. And therefore, I should raise an index error because I cannot pop an element from an empty list. Otherwise, I'm going to proceed as follows. I need to have a temporary variable, front node, which is going to point to the self.front. Here is just to be able to remember where the front is. Then I'm going to create a pointer to the next element from front. So here I can say that the front now is pointing to the next element of front. Then I need to do some cleanup. So here I'm going to look at the temporary variable front.node on the tail, and I'm going to point it to node. So in fact, I'm going to sever the link between the first node and the second node. And then self.front will point to the second node. That's the way to remove it. Again, I will have to be very careful to make sure I'm going to remove to 1 from the number of elements in my size, in my list. And finally, I want to return the value which was at the first position. So in that case, I'm going to use the temporary variable front node, and I'm going to return the data contained in that node. There is more that can be done, and that's something you will investigate during the practical session.